I love doing that. All right, so let's go back to our slides here. We talked about the complement, and then we've got the addition rule. And the addition rule is going to start off with this part right here. And it says that if you have events that have absolutely nothing in common, they are called disjoint. If you think about Venn diagram, they are circles that do not intersect. And what we could talk about here would be something like, oh, here's the probability of you drawing a 4, here's the probability of you drawing a king. There is no intersection of those groups because there is no 4 king. They are called disjoint or mutually exclusive. Disjoint and mutually exclusive are synonymous with each other, and you need to know both of them. Another way that you can think about it, here's the probability of rolling a 3, here's the probability of rolling a 6. There is no 3-6 side. They are disjoint or mutually exclusive. If we take a look at, for example, a two-way contingency table, and we can take a look at the variable of color on cards. On color, you've got red and you've got black, and what I could do is I could do a table that would be the breakdown of these variables. But then I'm also going to take a look at the value of the cards, and I can have a 2 or a 3 or a 4 or a 5 or a jack or a king, and I can sit there and say, oh, you know what? There are 2 red 2s and there are 2 black 2s and there are 2 red 3s and there are 2 black 3s. But when we talk about disjoint or mutually exclusive, what we're talking about, for example, 2 and 3, these are columns. They do not intersect at all. These values are disjoint because there is no 2, 3. 2 and jack, they are disjoint. Red and black, they are disjoint. They are both rows. There is no intersection. But 2 and red, those intersect. They are not disjoint. They are not mutually exclusive because there are 2 cards that are both red and 2. And that's where disjoint falls through right there, is that these are not disjoint. Black and 2 are not disjoint. Okay. Now, the addition rule says, if I have 2 disjoint events, A and B, meaning circles A and B that are separate, the probability of event A happening or the probability of event B happening is equal to the probability of A plus the probability of B. And it says, provided these are disjoint. We'll talk about what happens if they're not disjoint next chapter. And if you think about it, that makes perfect sense. Let's take a look at our die here for a second. If I say to you, what's the probability of rolling a 1, you say, oh, that's 1 out of 6. If I say, what's the probability of rolling a 2, you say, oh, that's 1 out of 6. But if I say, what's the probability of rolling a 1 or a 2? What you've done is you've increased the number of successes. So if we think about this in a fractional sense, the probability of rolling a 1 or the probability of rolling a 2 would be 1/6, according to the addition rule, would be plus 1/6, which would be 2/6. But if we just define it as success over opportunity, we'd sit there and say, oh, how many successes do you have? Well, a 1 would give me success, a 2 would give me success. I've got 2 out of 6. Now, is this fraction 1/3? And the answer is, you know what? Yeah, it is. But we are going to leave it as 2/6. And this is going to be making some of you very, very happy. You mean I don't have to reduce fractions, Mr. Fleming? I don't want you to reduce fractions in this situation, because this is a lot of information. If I say 1/3, all I know is that the probability is 1 out of 3. But if I leave it as 2/6, this tells me that there are 2 possible successes out of 6 total opportunities, and that's more information than 1/3. Because 1/3 is the same thing as 3/9. It's the same thing as 4/12. 2/6 is more specific, telling me exactly what's happening. And that's the information that I want. So we are not going to reduce fractions. Moving right along. Okay, the multiplication rule says for 2 independent events, A and B. That means that you have more than one event. You've got one event and then you have another event. The probability of A happening and then B also happening is a probability of A times the probability of B. Now, going backwards, let's see if we can go backwards. Here we've got a great phrase, and what we want to do with this phrase is we want to write down somewhere that OR means add, because it does. So somewhere, if you see the word or, you want to know that if you see or, you are going to add. So or means add. But we have an issue here because that makes us want to say that and means multiply. And we don't want to get stuck in that. When we see the word and, what we want to do is we want to ask ourselves, how many events do we have? Because this is going to be very helpful. If we have one event and we see the word and, for example, what's the probability that you get a card that is both red and a king? Now, you get a card, that means one event. We ask ourselves, what's the probability of getting a card that's red and a king? This is really just simple probability because you're asking yourself, how many cards meet this criteria? There are 2 out of 52 cards. That's all there is, 2 out of 52. Very easy. But if I said to you, what's the probability that you get a king and then you get a king? That means that you've got one event and then you have another event. So when you see the word and, the first thing you need to ask yourself is, how many events do I have? Now this situation here, if these are independent, meaning that I've done with replacement, the probability of getting a king is 4 out of 52, or a 2, we'll make that actually a 2. 4 out of 52, and then the probability of me getting a king, assuming that they're independent, is 4 out of 52. And if I want to find the probability that this event happens and then this event happens, and is going to mean multiply. So, if you see and, you have to ask yourself, how many events do I have? If I have one event, and means the intersection of those two groups. If you have more than one event, and is going to mean multiply. You take the probability of the first event times the probability of the second event, assuming, of course, that they are independent, because that's where we're going with this right now. We're actually going to find out what we do if they're not independent next chapter. All right. I don't like this slide, skip it. Here we go. Multiplication rule. All right. Many statistics methods require an independence assumption, but assuming independence doesn't make it true. What this means is you have to think. If you're pulling cards, is it with replacement or is it without replacement? What is the probability on that second event? Now we're going to talk about that more next chapter. For right now, we're probably going to go with everything is independent because that makes things easy for right now. Okay, notation. On your formula sheets, there's a probability page. That's the second page back. And what we're going to see, instead of the word or, we're going to see the union symbol. So the union symbol means or, which means add. So when you see this, you're going to add A and B. But for and, they use the intersection symbol, because that is the intersection of the two groups, like we were talking about for and if you've got one event. It's the intersection of those two groups. So this is the union symbol. This is the, intersection symbol. And you know what? You just have to memorize that. Just have to deal with it. Well, how am I supposed to know that? You're smart. Figure it out. This almost looks like an A. So maybe that helps you. I don't know. All right. When probability becomes interesting is when you start combining things. What's the probability that you pull a 4 and then you pull another 4? What's the probability that you roll a 3 and then you roll a 7? Beware of probabilities that, what can go wrong? Lots of things. Beware of probabilities that don't add up to 1. All your probabilities have to add up to 1. Is that an opportunity for a trick question? You betcha it is. All right? Don't add probabilities of events if they're not disjoint. We're going to find out that we're going to do that anyhow. Okay? Don't multiply probabilities if they're not independent. You know what? We're going to do that anyhow too. Don't confuse disjoint and independent. Disjoint events can't be independent. This is going to be kind of a big thing, and we're almost at the end of this slide right here. So what we're going to do is we're going to take a break, and we're going to talk about the difference between disjoint and independent in a second. Wait for the beat. Here it comes. There it is. Back in a second.